Welcome to Chem Talk, Breaking Down the Basics series.
Hello everybody, my name is Julian, and today we will be learning how to draw Lewis structures. Yay! Okay, first things first, I am going to go to our periodic table here. Hopefully you can all see that. If you look on here, Lewis dot structures are informed by a very important thing we learned from the periodic table, which is valence electrons. Now, valence electrons are actually shown on the periodic table because they're arranged in columns. As you can see right here, they're all in different columns, and those columns are called groups. So we have group 13, column 13, which is group 3A, meaning they have 3 valence electrons. Valence electrons being electrons on their outermost shell. Group 4A, 14th column, 4 valence electrons, 5, 6, 7 valence electrons. You get the idea. And we can use that number of valence electrons to help us determine how to draw Lewis structures. I'm going to stop this share. We're going to go to our handy dandy whiteboard right here. Now, the first one we're going to draw is CO2. So carbon is group 4, meaning it has 4 valence electrons. Oxygen is group 6, meaning it has 6 valence electrons. And we have 2 oxygens. So if you add up all those numbers together, 6 times 2 is 12, plus 4 is 16 valence electrons. That's how many valence electrons we have to draw with. Now first, we're going to put these together. So since there's only 1 carbon and 2 oxygens, we can assume that carbon's going to be in the center of our molecule. Now we're going to draw a bond, which we just represent as a single line to all the other elements within this molecule. Next, we fill up the other elements using lone pairs. So right now, these are our surrounding outer elements, and we use lone pairs. So 1, 2, 3, 4, 5, 6 to fill it up. Atoms are going to want to do what we call fill their octet. So they're going to follow the octet rule, meaning they want to be surrounded by 8 valence electrons. Every bond is a sharing of 2 electrons, meaning this oxygen has 2, 3, 4, 5, 6, 7, 8. So that octet is full. And this octet is now full, total of 8. But you might notice the carbon itself is not. It is only seeing 4 valence electrons, and it wants to see more than that. So we're going to have to start using double bonds, share more electrons. So we take one of these lone pairs and we share it with the carbon. So now carbon is seeing 2, 4, 6. Still not enough. So I'm going to take one of these double bonds, one of those lone pairs and share in a double bond. And now carbon is seeing 8. And if we count all the electrons, we have 2, 4, 6, 8, 10, 12, 14, 16. We have all our electrons. Now we're going to do another example, H2O. So O is alone, so it's going to be our central. And then we have 2 H's. Now I'm drawing it in a very specific way. You'll see why. First, let's determine how many valence electrons we're going to have. So H is in group 1, so it's literally just 1 valence electron, but we have 2 of them. Oxygen is in group 6. That's 6 valence electrons. Oh no, we have 8 valence electrons. Right? Well, hydrogen is special. It's in the very first row of the periodic table, the first period. And so it only needs 2 valence electrons to fill its octet. So if we look here, this is 2 and 4. Both these hydrogens are satisfied. So what do we do with the rest of the electrons? We put it in the central atom. So we're going to have 2, 4, 6, 7, 8. H2O is filled. Now on your own, you can try to do CO3 2 minus. Thanks for watching.
That's a wrap for today's episode of Chem Talk, Breaking Down the Basics series. Thanks for watching. If you enjoyed this video, don't forget to hit that subscribe button. Until next time, keep learning, stay curious, and we'll see you in the next Chem Talk, Breaking Down the Basics episode.